Hello everyone, welcome back to another video. Today we are going to discuss another room on TryHackMe and it's named as Web Application Basics. So we are going to learn the basics of web applications. We are going to learn about Hypertext Transfer Protocol. We are going to learn about URLs. We are going to learn about the request that our particular client or we send to the server hosting up the web application and how it gives us a response. How is the communication go from client, here in this case which we are, to the server which is hosting up the web application, what information this communication contains, and how it could be manipulated into doing unintended things as well. We are going to learn a basic overview of a web application. We are going to learn basics of web applications. We are going to learn about different requests. We are going to learn about different responses the server gives us during the communication between the client and the server. And we are generally going to cover a lot of interesting stuff. So without further, let's just jump into the introduction on, and it is the task number 1 as well. So welcome to the web application basics room. Okay, so this is going to be really fun. And in this room, we will walk through the key elements of a web applications, which are URLs and HTTP requests and responses. And it is perfect if you are starting and you want to generally get some hands-on onto the essentials. It is generally a beginner-friendly room. We are going to learn about the basics of the web apps and how it generally goes. The request generally goes from us to the server hosting the web application, and what could go wrong if someone is intercepting this communication, and everything that is laid a foundation of web application. We are going to cover it anyways. So there are a couple of learning objectives that we will cover throughout the room. We are going to understand what a web application generally is, and we are going to learn how it runs in a web browser. And we are going to break down the components of a uniform resource locator, which is URL in short. And we are going to see how it helps to access us the web resources. And we are going to learn about Hypertext Transfer Protocol's request. We are going to learn about the responses the server gives us, the request we send as a client, and the client server model. We are going to discuss this as well. We are going to get familiar with the types of HTTP request methods and understand what different response codes means and what the server is basically trying to convey to us by these server codes. We are going to basically learn the language of the servers and the language of the clients. Yeah, that's pretty much how we summarize this up. And I'm really ready and I'm really energetic to learn about web applications. Let's check mark this box. Okay, now we are gonna jump into the task number 2. So I am gonna just minimize this up. Okay, so here we are presented with a nice analogy. So consider an analogy of a web application as a planet. Okay. Astronauts travel to the planet to explore its surface. Okay. So similar to how someone uses a web browser to explore or browse a particular web application. Okay, so we only see the surface. A lot is going under the surface. And you can imagine the whole planet as a web server. And many things go under the surface of this web server. We don't see this even as an astronaut. So what this means is we generally don't know what's working under particular web application. How is it giving us the particular resource? What is getting done behind the screens? Or we say what is under the surface of that particular web application. So we are gonna get an idea of what is under the surface after this room, I guess, and we are gonna learn what are this even the surface and the thing under the surface, what is the name given to it. So the thing on the surface is called front end, and it can be considered something that is consisting the entire surface of our planet. What we see as an astronaut on the planet is the front end, and the parts that an astronaut can see and interact with based on the laws of nature is generally the front end, and a web application would have a user interact with it, and a number of technologies are involved in this interaction. A web application is based on its surface with the free number of technologies, basically free number of technologies. These are hypertext markup language, which stands for, which is in short HTML, and then we have CSS, which stands for cascading style sheets, and then we have JS, which stands for JavaScript. These three make up the surface of our planet, or in case we say the web application. The hypertext markup language can be considered as the body of the web application. Everything that is essential for a web application is given out in the HTML. It contains some set of instructions or code that tells the web browser what to display and how to display it. And it could be compared to simple organisms living on the planet. And these organisms have DNA, which is the instructions for how simple organisms are put together. So hypertext markup language is nothing other than simple instructions making up the body of the web application. I hope that's clear. And then we have CSS, which means cascading style sheets, which gives the beauty to our body of the web application, and it makes it more stylish. And we continuing our analogy with the DNA. This would be that describing the color, shape, and size of the simple organism. The body of the organisms or the instructions is generally stored in the DNA, and the color, shape, and size and the texture of the organism is also stored in the DNA as well. So yeah, I mean, styling of the body is generally called cascading style sheets, and the styling of the web application is generally CSS. As simple as that. And then we have JS, which generally handles all the complex activity in the web browser. HTML can be considered as simple set of instructions on what to display. JavaScript handles all the functionality. You can think JavaScript as the brain, and you can think HTML as a body, and you can think CSS as the beauty or the stylish clothes or some stylish accessories that a human being wears. So yeah, I think that's really the basics you need to understand. Then we have the backend. So with the previous analogy of our planet, we're going to continue. There are certain things that are involved under the surface of the planet. This is generally called backend in a major category, and we generally don't see it in a web browser, but it is really working under the back of the web application. These include several components. These are a database which stores everything of the users that interacts with the web applications, and as well it stores everything about the organization hosting the web application. It can be storing resources to be presented to the clients or users, and it could be storing us a lot about what to display, what to show, or what to retrieve, when to retrieve. Everything generally that is a data is generally stored in a database, as simple as that. And then we have a couple of infrastructure components that is essential to host the web applications. These are web server, application server, storage, networking devices, and in the analogy of our planet, these are the roads that are present, and the car that runs on the roads, and the fuel that powers the car, as simple as that. And then we have web application firewall, and this is basically a security guard that filters for dangerous persons or dangerous requests in our real web application, and it does so to prevent malicious persons to get hold of the web application and to prevent it from uh, harmful purposes. And planet in our planet analogy, it can be seen to protect inhabitants from harmful ultraviolet rays. A really nice example as well. So if I had to summarize all this, there are many components in delivering a web application. A simple web application would be involving a number of technologies. These technologies include some on the front, some on the back, and some on the front could be hypertext markup language, CSS, and JavaScript. And on the back, these could be database, web servers, or firewall. And these are all done in order to present us the entire web application. So jumping onto the questions of this task number 2. Which component on a computer is responsible for hosting and delivering the content for web applications? It's gonna be web server. And which tool is used to access and interact with the web applications? So generally a web browser is used. Web browser. Yeah. And which component acts as a protective layer, filtering incoming traffic to block malicious attacks and ensuring the security of the web application? It's going to be web application firewall, or WAF in general. Then we have task number 3, which is Uniform Resource Locator, in short URL. URL is basically a web address that lets you access all the things on the internet. It could be as simple as a web page, a video, or photo, or any other media. As simple as that. Then we have a nice URL here presented to us. Here we can see that we are visiting TryHackMe.com. This is a complex URL for now, but you can see that we are visiting TryHackMe.com. So you can think URL as being made up of several parts, each playing a different role. A URL basically tells what to access, what resource to access. As simple as that. So a URL contains a lot of information. It specifies everything to the web server to make it easier to give him the particular request of the client which we are to access the particular web application resources. And in order to do so, it needs a complete address, and that complete address is called Uniform Resource Locator. So the Uniform Resource Locator contains several key components. The first up is scheme. The scheme is the protocol used to access the website. The most common you are going to interact when you are visiting the web application is going to be Hypertext Transfer Protocol, but Hypertext Transfer Protocol secure HTTPS, but more often you are going to see HTTP as well. The difference between is Hypertext Transfer Protocol is generally a more secure as it encrypts the communication. What I mean by this is we are the client and the server hosting the web application is the server. So the communication between us and the server is going on in some manner, and if it's not encrypted, then any third party listening this conversation as such could potentially know what you are doing, and it is really dangerous if you are doing some sensitive information. So Hypertext Transfer Protocol Secure is more preferred as it is secure over Hypertext Transfer Protocol. And when you are trying to access a particular web application, you are going to be presented with these two protocols. Then we have the user, which generally contains some URLs can include, it is not essential, but some URLs can include information of the user. And the user, which we are, and here we are the client. So it contains information that is required to authenticate, and it generally contains credentials, and it is really rare nowadays since we get a login using a login page. So but more often, if there is a user field, then either the credentials are used to give the web server to authenticate us as ourselves. And then we have our entire host or domain, which is the most important part of the URL, which tells the website you are accessing. Every domain name is unique. It's not possible to have multiple domain names. Every house address is unique. So, as such, the complete domain is unique too. It cannot be uh, multiple for multiple users. So, even if you generally mistype it, for example, if I type on the tryhackme.com as tryhacku.com, then that's called typo spotting. It's what you generally do so by some random typos. Or if I'm not right, then you could just type tryhackm.com and you are presented with another domain, and it's called typo squatting. It's more often in the phishing scams being used to harm us in a bad manner. Then we have a port number in the uniform source locator. This tells us what protocol you are using to communicate with the server. The more often these are 80 or 443, it generally is what we call the doorway to use for communication. As simple as that, we have port numbers that you can remember that range from 1 to 65,535. These are all doing some different purposes. Then we have paths. As I demonstrated you previously, that the server would be containing some different files as well in the database. So you need to be specific what you are trying to access, and these would be generally files as well, as simple as files and the page you are trying to access. So yeah, it is specified on the path end as well, uh, on the uniform source locator URL. Then we have the query string, which is a parameter that is used for the search terms or inputs, and it is the user that generally does do so in the query to access a particular source in the web application. So as the users, we can inject some malicious inputs into this query and potentially harm the server to do the unintended purposes as well. So that's the query means generally you are trying to access a particular resource, what value it's doing. A query generally contains is using it for doing some particular purpose of the user. For example, if the user is trying to access a room, then it would be giving the ID of that particular room, or the anything to further specify what the user is trying to access is generally given in the query string. And then we have fragment, which is given by the hash symbol. The query string is given by the question mark symbol. The fragment starts with a hash symbol, and it helps to point to the specific section of a web page. Like if you are going to, for example, like here, see, we are in this web application room, and this web application room is generally given on the path web application basics. It's communicating over HTTPS 443 port, and the domain is tryhackme.com. And here we don't have user and password, since we are already authenticated and it's not used these days, but the scheme is HTTPS. If I show you, yeah, HTTPS. So this is our entire URL, and if I had to go to task 3, then I would use this fragment as such. Don't think it's gonna work for now, but you can see that if I want to jump to the task number 3 on this entire room, then I'm gonna use fragment. And the query string over here is generally can be used to give the particular room a particular value or the user a particular value as such. Now we are going to jump onto the two questions that we are asked. Which protocol provides encrypted communication to ensure the data transmission between web browser and a web server? A web browser is considered as a client here, as I already demonstrated you and I explained you previously as well. So the encrypted version is called HTTPS. And the second question is, which term describes the practice of registering domain names that are misspelled, various of popular websites to exploit user errors and potentially engage in fraudulent activities? That would be typo. Exploiting. I think I typed it wrong. There is double T if I'm not. Yeah, it is correct. So what part of the URL is used to pass additional information such as search terms or form inputs to the web server? And I already explained you that the further information that we give to the web server to access a particular need of the client is given in the query string. And with that, we completed our task number 3. Now let's jump on to the task number 4. These are called hypertext transfer protocol messages. So hypertext transfer protocol, we discussed earlier on, it's a protocol used to communicate between the client and a web server. A particular data is exchanged in this communication. We are generally the client. The client sends a request. A client sends a request and the server gives a response to us. It's as simple as that, the client-server interaction. And there are two types of hypertext transfer protocol messages. Either you are going to request or either you are going to get a response. So here you can see a simple request on the TryHackMe.com and a simple response as well. So if I'm not going to complicate it much, but let's start with the basics. So there is a one start line. Here you can see this particular, we are discussing, yeah. So the first line on the HTTP request and the first line on the HTTP response is conveying us that what kind of message is being sent, whether it's a request from the user or a response. If it's a request, it's going to be using some particular methods which we are going to discuss later on. Or if it's a response, it's going to be giving some particular status code indicating if the response would be for a particular request, the request would be for a particular response. As simple as that. So response would be indicating if the request was successful, it was altered, or anything related to the request would be given as in the response as well. And so from the starting line, we get an idea about what kind of message is it in the client server model. And then we have headers, which are the key value pairs that handle or that provides an extra information about this communication. And it gives instructions to both the client and the server regarding handling the request and the response. And it covers all sort of things like security, content types, and making sure everything goes smoothly in the communication. So here the headers are the host, the content type, and content length in the request, and on the response these are content type, content length, and the date as well. We are going to discuss this later on, but you can just see headers as some additional information being given. during the communication between the client and the server. And then there is this empty line, which is used to separate out the headers from the body section. Body section, which we are going to cover now, there is this empty line. So it's generally used to make the clear view about the headers and the bodies. And yeah, as simple as that. The body, which stores the actual data that is being sent between this client and the server interaction. So by understanding this hypertext transfer protocol messages even matters. So these are the foundation about how the client is communicating with the server hosting the web application. And if you could alter this communication, you could just mess around with the server to do unintended purposes. So whether you are a technical guy, you should know how you are being using this particular web application, because anything could go wrong and you need to know how it works as such. And if you are into security, then it's must have to know about these messages and this communication. So without further, let's just jump into the questions. We have the first question of the task number 4, which is, which hypertext transfer protocol message is returned by the web server after processing a client's request? So a request generally gives us a response, and the response is being done over a particular request. And then we have what follows the headers in a hypertext transfer protocol message. That's going to be an empty line. So it's used to separate the headers with the body. And with that, we are going to complete the task number 4. Then we are going to move to the task number 5, which is given the title of hypertext transfer protocol request, request line, and methods. So we are going to learn what is a request. So request is what the client or we make to the server hosting the web application to access that particular resource in the website or in the web server. As simple as that. And here we can see a simple request being sent by us as the client to the web server. There is a method, there is a path, and I think it's going to be complex. Let's first look at what are the key parts involved in the hypertext transfer protocol request. There are certain elements that are involved when we are communicating, when we as a client are communicating to the server. The first line is the request line, which is the first part of the hypertext transfer protocol request, which tells the server what kind of request it's dealing with. So keep in mind that we are the client and we are communicating with the server. We need to tell what we want to the server. So here we are telling the first line that we want to either get your particular resource, or we want to post down some particular resource, or we're going to delete some particular resource, or a couple of other hypertext transfer protocol methods that we need to specify to the server what he's going to deal with. This particular request line would be containing the method, the URL path, and the version. And a simple example on this request line would be method. Here you can see method with a path with the version. It's going to tell the server, we as a client want to tell the server everything we want. It cannot give us without telling, as such, as simple as that. So we are going to specify what method we want, like either we want the resource, we're going to post down the resource, we're going to delete the resource, or other communication we want to do with the server. What resource do we need to work on, and what version is we need to work on from the server as such during this particular communication. So the HTTP version means the version of this communication. There are a couple of versions out there used for this communication. Some are more updated, some are less updated. So yeah, that's particularly as simple as that. So the first methods that we can use to communicate with the server could be get. We want the data from the server. So we say to the server, we want this data. So in this communication with the server, we might end up exposing our sensitive data in the URL. So if the server is not using a secure mechanism or a secure login page, and it's using what we discussed in the previous uniform source locator, that this user and password is being supplied as in the URL as such. So it's quite possible that here the similar mechanism would be that it is generally giving these credentials in the plain text in this particular GET request. So it's not recommended to do so as such, and there are a couple of other mechanisms you need to consider when you are dealing such and such authentication. But generally, it is not recommended to do so in the GET request. You just use the GET HTTP method for fetching the data. And the post as means, if you know that post uh, means to post on something, the postal code, the post service, and it's clear from the name as such that it's gonna send the data to the server to create or update something. And here, a nice gentle reminder by the TryHackMe has given to always validate and clean the input to avoid any tags like SQL injection or cross-site scripting. We are discussing it from the security point of view, so we need to consider how it could be abused as well. And then we have put. The put HTTP method basically replaces or updates something in the server, and it makes sure the user is authorized to make changes before making the request, and it's a reminder from TryHackMe as a security point of view. Put is also clear from the name as well that it means to put something on the server. And yeah, the delete means to remove something from the server, and a gentle reminder from TryHackMe as a security point of view that just like with the put, make sure only authorized users can delete down their sources. So behind these common are some other that can be used as well. And their patch can be used, which updates part of a resource. The head can be used, which works like get but only retrieves particular headers. The options HTTP method can be used as such, which tells what methods are available for accessing a particular specific resource, and trace can be used, which is similar to options, which shows which methods are allowed, and it is often used for debugging, and many servers generally disable it for security reasons. Then we have one last hypertext transfer protocol, a request method, which is connect, which is used to create a secure connection, like for hypertext transfer protocol, secure HTTPS in short. So each of these methods has its own set of security rules. For example, patch requests should be validated to avoid inconsistencies, and options and trace should be turned off if not needed to avoid possible risks. As simple. So the URL path tells when we are requesting particular thing, it tells the server what do we want out of that particular request, and it generally contains the path of the URL. What do we want? And as a security point of view, you need to validate the URL to prevent unauthorized access, and you need to sanitize it to prevent injection attacks. It could be abused as well. You don't need to expose some sensitive parts like an API endpoints, which could be handling all the users' information. Then we have a couple of visions that generally handles the communication between the client and the server, and there are a couple of ways the client and the server can communicate with each other. One of the most common is HTTP 1.1, 2, and 3, and HTTP 1 as well. The 0.9 is the first version that only supports GET requests. The 1.0 added headers and better support for different types of content, and 1.1 basically brought persistent connections and chunk transfer encoding, and is generally used widely today. And the two introduces more modern features like multiplexing, and it's more modern. And free on the top of it adds a new protocol which is QIC, and it's used for more secure communications. These are different ways of communication between the client and the server. Many systems still use 1.1, and 2 and 3 are generally new. So we are gonna answer out the questions in the task number 5 of the web application basics room. So let's start with the first question. Which hypertext transfer protocol version becomes widely adopted and remains the most commonly used version for web communication, known for introducing features like persistent connections and chunk transfer encoding? So that would be 1.1 if I'm not wrong. And 1.1 is most used. 1.1. Yeah, which hypertext transfer protocol request method describes the communication options for the target resource, allowing the clients to determine which hypertext transfer protocol methods are supported by the web server? So that's gonna be options if I'm not wrong. And on the last question, in the hypertext transfer protocol request, which component specifies the specific resource or endpoint on the web server that the client is requesting? So what the client is requesting is given out on the URL path. And with that, we completed the task number 5 as well. Now jumping on to the task number 6, which is gonna be about the headers in the request of the communication between us and the server. And request headers allow some extra information to be conveyed to the web server about the particular request, and it gives some additional information to the web server. As simple as it is. So some common request headers would include a post which specifies the name of the web server the request is for, and the user agent which shares information about the web server the request is coming from as the client, and the referer which indicates the URL which the request came from, and the cookie, the information the web server previously asked the web browser to store is cookie. A cookie is basically generally the collection of the data. Everything the user is doing on the particular web application is stored as a cookie, as a particular session identifier that holds out all the particular data of the user and all the progress. As simple as that. The headers here are trying to give out more information about this communication. These headers are some, like the most common ones are host, user agent, referer, which and the referer indicates the URL the request came from. Originally, the Google can be resourced to access the particular TryHackMe. For example, if you search on the Google TryHackMe.com, then the request being sent to the TryHackMe would having a referer as Google.com, like you were navigated from Google to TryHackMe. As simple. And user agent tells what we, the client, are using to access the particular resource on the web server. And cookie I already explained you. And the content type describes what type of format is the data being which the client wants. And then we have the request body. In hypertext transfer protocol requests such as post and put, where data is sent to the web server as opposed to the requested from the web server, the data is located inside the request body. The body contains all the communication between the client and the server. Before, we were trying to establish a communication between the client and the server. Now we are going to tell what do we want out from the server, and it's going to contain out everything a body would contain. Like a body would contain everything essential. So yeah, body defines what do we want as a client from the web server. So the formatting, it's generally more common that we see name and some certain value being passed out on the body. And if I read this up in HTTP requests such as post and put, where data is sent to the web server as opposed to the requested from the web server, the data is located inside the HTTP request body. Okay, the main data is stored in the body. The formatting of the data can take off many forms, such as URL encoded form data. Okay, there are a couple of methods that can be used for this formatting of data. One of it is URL encoding, which is a format where data is structured in the pair of keys and given a particular value. So multiple pairs are separated by an and symbol, and a couple of keys here we are giving out, or we are giving out the particular name Alexandra, having the age and the country US in the body of the request. Then we have form data, which allows multiple data blocks to be sent, where each block is separated by a boundary string. The boundary string is defined header of the request itself. This type of formatting can be used to send binary data. So, for example, the binary data such as image can be sent up in this form data. Form data clear as well. It's gonna be particular data. And yeah, then we have JSON. In this format, the data can be sent using the JSON, and the JSON is generally in the curly braces there, where we have a particular name having a particular value, particular keyword having a particular value as such. And these are all the uh, data formatting being used in the request body. Like you use some certain techniques to format out the body to match the server's language, what to say to the server for the particular resource as such. And we give it in the body having a couple of different formattings. One of it would be URL encoding, or application having multiple values and just it's being URL encoded. Then it could be form data as such, giving you when you are uploading files or using some binary data to send to the server. JSON, you are using a particular keyword for having a particular value. XML, where data is structured inside labels for it tags. Here you can see it's more familiar with the HTML. If you have ever used HTML, there are tags as well, the body, and XML is basically that you are giving out the data. Now let's jump onto the questions here on the task number 6. So the first question that we are asked, that which hypertext transfer protocol request header specifies the domain name of the web server to which the request is being sent. So it's gonna be the host, which specifies the host contains domain name. And what type is the default content type for form submissions in an HTTP request, where the data is included as key value pairs in a query string format. We already discussed that it's gonna be URL encoding, where it is all separated down using the and symbol application, and it's gonna be like this if I'm not wrong. On URL, don't know, I'm not sure if it's gonna be right, but let's try to make a blind shot. Okay, so it's right. Then we have the last question, which part of a hypertext transfer protocol request contains additional information like host, user agent, and content type. The additional information is generally passed in the headers. And with that, we completed task number 6 as well. Now jumping on to task number 7, which is given the title of Hypertext Transfer Protocol Response, Status Line, and Status Codes. So we discussed the task number 5 and task number 6. We as a client are talking to the server what do we want and how we are communicating with the server about our needs from it as a web server. And here now the server is going to communicate back to us with its own particular language, which we need to understand. So when you interact with a web application, the server sends back a response to let you know whether your request was successful and whether it was complete failure, whether the web server could provide you what you want or it could not provide you. It's all just given there from the first line of the response, which is the status code, which means the reason phrase, which tells if it handled the request and if it generally could give you what you want or not. As simple as that. The first line is the status lines, which contains three generally key pieces of information: the version of the communication we were using to talk with the server, the status code, a three-digit number showing the outcome of your request. These are pre-configured and it tells whether he could provide that particular resource or it was a complete failure. Everything, the result of the request of your request as a client is shown in the status code. And then we have a reason phrase, a short message explaining the status code in human readable terms. For example, 200 means found, and the found is the reason phrase. The a short explanation here is also given out in the response. For that, every human reading out this communication can generally focus on it. So we already covered versions in task number 5, that these are a couple of modes of communicating a client to the server. And the status code is the number that generally tells if your request, the result of your request, and the reason phrase explains in human readable terms. So typically informational responses means are generally range from 100 to 199, and these means that server has received a part of the request and is waiting like it's waiting to give you it's waiting for you as a client to continue on, like it's saying okay, it's listening, okay, I'm listening, continue your further conversation. And the 200 means okay, the server says to us that okay, I've listened your request and okay, I'm ready to give you what you want. And it means the request was successful. And the redirection means that I cannot help you, you need to go somewhere else. As simple as that, redirection, and it ranges from 300 to 399. And the client error responses means that the server basically says that these resource has been moved to a different location. It says like, I don't have this resource, and if I'm not sorry if I miscorrect, it's client error responses and the 400 to 499, and the server says that these code indicate a problem with the request. Like I don't know what language you are speaking, man. I don't know what do you want. I just don't know what you are even saying. And if the URL is wrong, it says that, or if you are missing some authentication, then as well it would say that I don't know, man, who are you? Why should I even listen to your request as such? Then we have server error responses, where the server basically tells us as a client that I have an error fulfilling the request. I don't know if I cannot complete your request, and I know it's not your fault. It's some error on my side, but I really apologize to you for this. And such type of responses generally range from 500 to 600. And some common status codes include 100, means the server got the first part and is ready for the rest. The particular 100 to 119, 100 is more common here, and it means to continue. In human language, 200 means okay, 301 means that I don't have it, man. I don't know where it's now. The server basically says move permanently in the human language, and 404 means not found. I don't have it, man. I don't know what do you want. And 500 means that I know, I understand your request, but I don't know. I can't just complete this request, and there's some internal server error, and there's no problem on your end. It's problem on my end. Then we have, and then we move to the questions here of the task number 7. Okay, so what part of the hypertext transfer protocol response provides the hypertext transfer protocol version, status codes, and a brief explanation of the response outcome? So we discussed that it was status line, if I remember correctly. I hope. Yeah. So then we have which category of hypertext transfer protocol response code indicates that a web server encountered an internal issue or is unable to fulfill the client's request. So it's gonna be the server side error responses having 500. Let's just paste this. And the last question, that is which hypertext transfer protocol status code indicates that the requested source could not be found? That's 404, a particular most famous as well. Status codes among all these. Now we move to the task number 8, which means the headers of the response, which gives us the additional responses of the server other than a particular some useful important lines and status codes. It tells more about the request response, the response it's gonna give of the particular request. So it's gonna first contain key headers like content type, content length, and date. And it could be as such, like headers could be anything that the server is pre-configured to give out. More commonly, it's content type, content length, and the date of the request. The required response headers are crucial for making the hypertext transfer protocol response works properly, and they provide essential information to the both client and server to process everything correctly. And here are some really few important ones. And it's pre-configured on the server and depends from server to server what response headers do we gonna get, but it's gonna basically tell more about the response of a particular request. The date header was gonna be tell about the exact date and time when the response was generated by the server. The content type is gonna tell what kind of content, it's getting, and whether it's hypertext, markup language, JSON, or something else. And the server hosting the web application, it tells us about himself, like who am I. And there are some other common response headers like set cookie, which after a successful authentication gives us a particular unique value, which is generally used to authenticate us every time. So client first, for example, if I'm the client and I'm trying to access the web application and I'm an administrator of this TryHackMe, I go to the web server and I say I'm the administrator of TryHackMe. The server says prove it by giving the credentials. We give us the credentials, and the server says, okay, I got it. You are the administrator. Here is your take token. You need to give this token to me, and I'm just gonna do everything for you. And so this is stored in a cookie, and the set cookie headers give this particular token. And the cache control basically tells the client how long it can cache the response. Basically, some used to give how long should this temporary information should be stored. And the location is gonna be that this one is generally used in the redirection responses, which tells where the new when I explained you the status code, I told you that the service says, hey man, I don't have this resource, but I know a particular person who have this resource. I'm going to give you the location of it, and the location header contains that particular exact location, as simple as that. The response body, the hypertext transfer protocol response body, is where the actual data lives. Things like HTML, JSON images, and that the service sends back are in the response body. And to prevent some injection attacks in this response body, always sanitize the input. So now we are going to jump back to the task number 8 questions over here. So the first question is, which hypertext transfer protocol response header can reveal information about the web server software and a version, potentially exposing it to the security risk if not removed? So it was server, I guess. Yeah, this one server. Server. Then we have another question, which flag should be added to the cookies in set cookie hypertext transfer protocol response header to ensure they are only transmitted over hypertext transfer protocol secure, protecting them from being exposed during unencrypted transmissions. So it's gonna be secure, if I am right. Yeah. And then we have the last question, which flag should be added to the cookies in the set cookie hypertext transfer protocol response header to prevent them from being accessed via JavaScript, thereby enhancing security against cross-site scripting attacks. If I am not wrong, it's gonna be HTTP only. Yeah, HTTP only. If I'm right, yeah. Now we move to the task number 9, which is given the title of security headers. So hypertext transfer protocol security headers help improve the overall security of a web application, and we are gonna learn how to prevent the attacks such as cross-site scripting. We are gonna learn how to prevent from clickjacking, another type of an attack. We are gonna learn how these security headers are used to prevent the attackers from doing malicious purposes. You can use a site like this to analyze the security headers, securityheaders.io, to check that out if you're interested. Then we have content security policy, CSPs, and additional security layer that can help to prevent common attacks. And common attacks would be like cross-site scripting. The malicious code could be hosted on a separate website and injected into the vulnerable website. So content security policy provides a way for administrator to say what domains or sources are considered safe and not to just blindly trust some malicious website, even if it is passed as such. And within the header itself, you may see properties such as default source or script source, script SRC, defined, and many more. Each of these give an option to an administrator to define at various level what domains are allowed for what content, as simple as that. Looking at the simple CSP header, content security policy, default SRC. Okay, default SRC specifies the default policy of cells, which means only the current website. And then script SRC means which specifies the policy for where scripts can be loaded from, which is self along with scripts hosted. So it tells the web server to only generally consider the scripts hosted as on the TryHackMe.com, and don't just trust out some malicious websites JavaScript and execute it blindly. So it would be hijacked. And the style SRC tells to only trust the our own TryHackMe.com styling as CSS file, not to trust some other person's other malicious domains CSS file. Yeah. Then we have another header, which is strict transport security policy, which in short is So here it is a simple HSTS strict transport policy having a max age and includes subdomains. The max age contains the expiry times in seconds for this setting, and include subdomains is an optional setting that instructs the browser to also apply the setting to all subdomains. And then we have preload, which is an optional setting that allows the website to be included in preload list. And browsers can use preload based to ensure HSTS before even having their first to a website. And then we have X content options, which is a header used to instruct browsers not to guess the type of resource, but only use the content type. Here, a general common example is X type content options. No snip means to not strip or guess the MIME type. And if you don't know what MIME is, it's a multi-purpose internet mail extension. And yeah, then we have refer policy, which this header contains the amount of information sent to the destination web server when a user is redirected from a source web server, and such as when they click a hyperlink. So it's going to tell the web administrator to control what information is secure, what information is shared. Common example of refer policy could be no refer, which means this completely disables any information being sent about the referrer. And the referrer is where the request is originally coming from. For example, if you search TryHackMe.com on the Google, then Google is your referrer. And the no referrer basically means to disable any information being sent about the referrer. And the same origin means this policy will only send referrer information when the destination is the same as the origin. And the strict origin means this policy only sends the referrer as the origin when the protocol stays the same. For example, HTTPS over HTTPS. And the strict origin when cross origin is similar to strict origin except for the same origin request, and when it sends the full URL path in the origin headers. So it's a mixture of same origin and strict origin. Yeah. Then we have questions at the last, that in content security policy CSP configuration, which property can be set to define where scripts can be loaded from? That could be script src, if I'm not wrong. Script src. Yeah. And then we have another question, when configuring a strict transport security HSTS header to ensure that all the subdomains of a site also use hypertext transfer protocol secure, which directive should be included to apply the security policy to both the main domain and its subdomain? It's going to be include subdomains. Include subdomains. And then at last we have which hypertext transfer protocol directive is used to prevent browsers from interpreting files as a different MIME. So that was the NoSnip. And with that we completed our task number 9 as well. Now we have a practical over here. Take the view site button on the to launch a static site in the split view. Okay, let's see. Skip. No, I don't want a tutorial. So we are given a cool instance over here. We'll make a get request to API users. Okay, so there are a couple of methods. I'm going to make a get request to API and users. Let's see what do we get. Oh, okay, so we have our first flag over here. TryHackMe, you have found the user list. We have a couple of users, Alice and Bob over here, and on the body of the particular request we get the particular tag. And now we have another task to make a post request to API user 2 and update the country. And as we discussed previously, the post request would be containing some data to be posted down to the server. And here we are gonna post down the data to API user and the user number to key. And to update the country, API user to, let's give a post request. And where could I change up the users? Okay, so I'm gonna set this country, the key value pairs, the country, and update the country of Bob from US, from UK to US. Change it to US. Am I the Bob? I don't know. Anyways, user to successfully updated. Make a post request. Let's see what do we have at the end over here. Watch out for case sensitivity. Okay, wait a second. Make a post request and update the country of Bob. Okay, I'm gonna give, I guess I need to give one more. Bob, giving the country. No, I don't think so. Country US. And this should work, I don't know. Let's get, okay, so we have a flag here. Let's go. And then we have make a delete request to API user 1. Okay, I'm going to make a delete request to API. I'm going to delete the user. And okay, we just deleted the user as well. And it was a really great lab. With that, we completed our task number 10. And with that, we completed out the room as well. So you completed all the tasks. We learned a lot in this room. I'm just going to conclude this. I hope you enjoyed this room. And thanks for watching.